Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The lowest energy chair conformation of a substituted cyclohexane is the one that places the maximum number of substituents in equatorial positions, thereby minimizing 1,3 diaxial steric interactions. Moving on to the next step. The compound is 1s2s4r 1,2,4-trimethylcyclohexane. We need to determine which chair conformation places all three methyl groups or the maximum number in equatorial positions. Moving on to the next step. A shows a chair with one methyl axial up at C1 making two methyls equatorial and one axial not all equatorial. B shows a chair with two methyl groups axial, high energy, not the lowest. C shows a chair conformation where all three methyl groups appear in equatorial positions. This is the lowest energy arrangement. For the 1s, 2s, 4r configuration, one chair conformer allows all three substituents to be equatorial simultaneously, and this is depicted in option C. D shows a chair with two axial methyl groups higher energy than C. And for the final step, in the correct chair flip for 1s, 2s, 4r 1,2,4-trimethylcyclohexane, the relative cis trans relationships between the methyl groups allow all three to occupy equatorial positions in one chair conformer. Option C depicts this all-equatorial arrangement, which is definitively the lowest energy conformation. Options A, B, and D all show at least one axial methyl group, introducing 1,3 diaxial strain and making them higher in energy than C. Therefore, the correct answer is C. Therefore, the correct answer is option C.